For each of the following rejection regions, sketch the sampling distribution of T and indicate the location of a rejection region on your sketch. Okay, number A, we have T greater than 1.440. The degree of freedom is 6. So let's draw the sampling distribution. So this is our sampling distribution. This is our T, and T, so if our T is greater than 1.440, then we reject. So that is our rejection region. So let's say our T is 1.440 here. So if our T is greater than 1.440, it means if T is on the right side here, then we reject our null hypothesis. So this is our rejection region. For part B, let's start with the sampling distribution. This is our sampling distribution. If T is less than negative 2.567, then we reject our null hypothesis. So that's a negative. So we take somewhere here. So negative 2.567. So everything on the left of this number. So if we have T which is less than negative 2.567, then we reject our null hypothesis. So this is our rejection region. For part C, if our T is less than negative 2.086 or if T is greater than positive 2.086, we reject our null hypothesis. So this is T, let's say this is our negative 2.086 and this is positive 2.086. So less than means everything on the left of negative 2.086, greater than means everything on the right. So if your T lies in this shaded region, then we reject our null hypothesis. Next here, so here we have a survey, online learning survey of online learning and going the distance online education in the United States 2011. So this is our survey, and it reported that 68% of the college presidents believe that their online education courses are as good as or superior to courses that utilize traditional face-to-face instruction. Okay, so what they believe, from that survey, it reported 68% of the college presidents believe that their online educations are better or superior to the courses that utilize traditional face-to-face. Now here they reported in terms of percentage. Okay, so we have to identify our parameter. So percentage means it's the P. So our P is the parameter. In first question, we are asked to give the null hypothesis for testing the claim made by this survey. So our null hypothesis is H naught. Let's start by writing a parameter. Our parameter is P and P is equals to, so what is the claim? The claim made by the president is that 68% is that their courses are good or as superior to courses that utilize traditional face-to-face instruction. Okay, the percentage of the college president that they believe this is 68%. So P equals to their claim is 68%, which is 0.68. So this is the our null hypothesis. For B, give the rejection region for a two-tailed test using alpha equal to 0.01. So it's a two-tailed test. So if we have a two-tailed test, we have the rejection region on the left side and on the right side. Okay, our rejection region alpha is 0.01. So we have rejection region on the left, we have rejection region on the right, and the sum of these two area is 0.01. So each area would be equals to half of 0.01. So half of 0.01 is 0.005. So this is 0.005, this is 0.005. So this is our rejection region. So here I think we can also find, or we can also write down our rejection region in terms of g. So let's find the g for this point. We have 0. So the area for this is 0.5 minus 0.005, which is 0.495. Now we use our g table, look for a number close to this, and the corresponding g value will be the g for this point. So let's go to the normal table. 0.495. So let's look for 0.495 here. 495. Okay, 0.495. 495. So here this and these two are closest to each other. So 0.495 is close to this 0.4949 and 0.4951. So we take the average of 2.57 and 2.58. So for this our g is 2.57, plus for this that's 2.58. We take the average because 0.495 is at equal distance from these two. So let's find the average here. 2.57 plus 2.58 divided by 2, we get 2.575. So this is our g for that point. So our g is on the right side is positive 2.575, and this is on the left side, which will be negative 2.575. Okay, so our rejection region is that if g is greater than 2.575 or g less than negative 2.575, then we reject our null hypothesis. Okay, next here, the US Department of Agriculture's National School Lunch Program mandates that for a high school to receive a reimbursement for a school lunches, the number of calories served at a lunch must be no more than 850 calories. Suppose a nutritionist believes that the true mean number of calories served at lunch at all US high schools exceeds 850 calories. We need to identify the parameter of interest. Our parameter is mean, which is mu, and it's also asking us to specify null hypothesis and alternative hypothesis. Let's start with the alternative hypothesis. Specify null and alternative hypothesis for testing this claim. Now what are their claim? So they claim or they believe that the true mean of a calories served at lunch exceeds 850 calories. It means their claim is mu is greater than 850 calories. So this is the claim made by them. We wanted to test this one. So this is our alternative hypothesis. Null hypothesis will be parameter mu equals to a number close to this alternative hypothesis, which will be the same 850. Okay, next here we can consider the test. So here we have our null hypothesis. H naught is mu equals to 7, and for each of the following we have to find the p-value. So a, so let's start with distribution here. This is our upper tailed test. Okay, we have upper one tailed test. Now for upper one tailed test, our rejection region is on the left side. Okay, and we want to find the p-value when our g is 1.20. So let's say 1.2 is here, that's 1.2, and so the p-value means this is the, since this is the upper one tail test, p-value will be the area on the right of this 1.2. so this area is the p-value. So we know this is 0. Now let's find the area of this region. Since the g for this point is 1.2, so we find 1.2 and corresponding area. So 1.2, 1.2 is here, 1.20, so 0.3849, 0.3849. So this is the area for this region. Everything on the right of 0 is 0.5, so this area would be 0.5 minus 0.3849, and this is 0.5 minus 0.3849 will be 0.1151, and this is the p-value. Okay, next we have HA. So for B, our alternative hypothesis is mu is less than 7, and mu is less than 7, and our G is equals to negative 1.2. Now in this case, this is our lower one tailed test. So this is our lowered one tailed test. So the rejection region is on the left side. Our G is negative 1.2. Let's say this is negative 1.2. This is origin, and the p-value will be the area on the left of this negative 1.2. Okay, now as like this part A, this area would also be 0.3849, so the area would be 0.5 minus 0.3849, which is equals to 0.1151. This is the p-value. Now next we have number C. Our alternative hypothesis is mu not equals to 7, not equals to 7, and our G is equals to 1.2. Now this is a two-tailed test. Okay, so we have not equals to, so two-tailed test, so we have the rejection region on the two side. Okay, so this is 1.2, this is negative 1.2. It means the p-value is on the two side. So the area on the left of negative 1.2 and the area on the right of negative 1.2 is the p-value. From part A and part B, we know this area is 0.1151, and this area is also same, 0.1151. So the p-value would be 2 times 0.1151, and this is equals to 0.2302. So this is the p-value for our two-tailed test. Now let's go to the next one. Our null hypothesis is given, alternative hypothesis is given. So let me write down null hypothesis mu equals to 50, alternative hypothesis mu greater than 50, a sample of n, so our n is 100, x bar, the mean of sample is 49.4, the standard deviation s is 4.1. We are asked to find and interpret the p-value for this test. Now we already have the all hypothesis, null hypothesis, alternative hypothesis. Now let's go ahead and find the test statistics. Our sample size is 100, which is large, parameter is mu. So if our sample size is large and parameter is mu, then the test statistics would be, so here, so large sample mu parameter, so our test statistics would be, so our sigma is unknown, so this would be the test statistics, x bar minus mu so our test statistic g, let me write down g of t for our test statistics. This is x bar minus mu divided by standard deviation square root of n. So our x bar is 49.4 minus mu is 50 divided by s 4.1 divided by square root of 100, and this is 49.4 minus 50. 49.4 minus 50 is negative 0.6 divided by the square root of 100 is 10. 4.1 divided by 10 is 0.41, and negative 0.6 divided by 0.41 is negative 1.46. So this is our test statistics. Now let's go ahead and draw our rejection region. Now our alternative hypothesis is upper one-tailed test. So upper one-tailed test, this is 0, so our g negative 1.46 is here. Okay, so rejection region, we don't have a rejection region, but what do we know? This is our upper one-tailed test, so the p-value would be the area on the right side, like here. So when we have upper one-tailed test, our rejection region is on the right side of test statistics. So this is our test statistics, so the area on the right of this test statistic is our p-value. So this area is p-value. We know this area is 0.5. Now let's find the area. So let's find this area from our normal table. We look at g equals to 1.46. So 1.46, 1.46 is here. So 0.4279, 0. So this is 0.4279. So the p-value is 0.5 plus 0.4279, which is 0.9279. Okay, so now what does it mean for us? So if our rejection region, okay, if this is our p-value, okay, and if our rejection region is small than this number, then we So we reject our null hypothesis. Okay, the next here we have our null hypothesis mu equals to 10, alternative hypothesis mu not equals to 10, sample size is 50, x bar is 10.7, standard deviation is 3.1. We are asked to find and interpret the p-values. Very similar. Let's start with finding the test statistics. Our sample size is 50 and our parameter is mu. So this is a large sample size with a parameter mu. So test statistic would be g statistic like previous example, and this is x bar minus mu divided by s square root of n. So x bar is 10.7 minus mu 10 divided by 3.1 over square root of 50. Now if we simplify this, so 10.7 minus 10, that is 0.7 divided by 3.1 divided by square root of 50. Okay, let's find the square root of 50. So that is 7.07. So this is 0.7, 3.1 divided 7.07, that is 0.438, 0.7 divided by 0.438, that is 1.598, which is 1.60. So this is our test statistic. Now let's draw a rejection region. Since this is our what kind of test? Two-tailed test. So we have the rejection region on the two side, and we will have a p-value on the two side. So this point is 1.6, this is 1.6. So the area on the left of 1.6, okay, the area on the left of 1.6 and the area on the right of 1.6 is our p-value. So this is our 0. Now let's go ahead and find this area. Since we know the g for this point is 1.6 from our normal table, so 1.64452, so 0.44, so this is 0.4452. In the similar way, this area would also be 0.4452. Now we can find this area, which is 0.5 minus 0.4452, and this is equals to 0.5 minus 0.4452, 0.0548, and which is same for this region, 0.0548. So p-value would be this sum of these two area, so that is 2 times 0.0548, so times 2, 0.1096. Next here we have according to theory in psychology, young female adults show more emotional empathy towards other than do males. A study tested this theory by examining the attitudes of the sample of 36 female college students. Each student completed the ethic of care interview, which consisted of a series of statements on empathy, attitudes. For the statement on emotional empathy, the sample mean response was, so our sample mean is 3.28. Assume that the population standard deviation for the female is 0.5, so this is the population standard deviation. Note that empathy scores ranges from 0 to 4, where 0 is never and 4 is always. Suppose it is known that male college students have an average emotional empathy score of 3. So it is known that a male college students have an average emotional empathy score of mu equals to 3. Now we need to complete the following parts. Specify the null and alternative hypothesis for testing whether female college students score higher than 3. So we want to have a null hypothesis, alternative hypothesis in order to test whether they have higher than 3.0. So let's write down our null hypothesis, alternative hypothesis, our parameter is mu. Okay, we want to test that whether the female college students score higher than 3.0 on the emotional empathy scale. So what we want to test? We want to test the mean is greater than, higher means greater than. So we want to test mu is greater than 3. Our null hypothesis would be mu equals to 3. The next we have to compute the test statistics. Our sample size is 36, which is large enough, and our parameter is mu. So our test statistics would be test statistics g of t is equals to x bar minus mu divided by sigma divided by square root of n, because standard deviation of a population is given. X bar is, what is our x bar? X bar for the is that's 3.28, mu is 3 divided by sigma is 0.5 divided by square root of n, n is 36. So 3 minus 2.8, 3.28 minus 3, 0.28 divided by 0.5 divided by 6, 0.28 divided by, now 0.5 divided by 6, 0.8, sorry, 0.083, and this is 0.28 divided by 0.083 equals 3.37. Okay, this is our test statistics. Find the observed significance level p-value for the test. Okay, let's go ahead and find the p-value. Our we have upper one tilt test, so the p-value is the area on the right of 3.37. So this is 3.37, and area on the right of this is 0. So let's go ahead and find this area 3.37. Okay, we have 3.3. So which is close to 0 of like, since the area for the G 3.09 is 0.4990, the area for 3.37 would also be 0.4990. So the area would be, the p-value would be like almost 0, okay, or close to 0. Okay, so the area is close to 0 because this area, so the total area on the right of 0, so the total area is 0.5, and from our table this yellow region is almost 0.5, so the green region would be almost equals to 0.0. At alpha equals to 0.01, what is the appropriate conclusion? Now our p-value is almost 0, right? And our alpha is 0.01, so our alpha is greater than p-value. It means this green region is in the alpha rejection region. Okay, it means we reject our null hypothesis. Reject null hypothesis because the p-value, okay, our p-value is less than alpha, which is 0.01. P-value is 0. Next, a sample of 5 measurements randomly selected from a normally distributed population resulted in summary. So we have these measurements from our sample. Our sample size is 5. We are asked to write down null hypothesis. So we have to test a null hypothesis that the mean of the population is 6 against the alternative hypothesis mu less than 6. So our null alternative hypothesis is given as mu less than 6. Null hypothesis would be mu equals to 6. Alpha is 0.05. Now let's go ahead and find test statistics. Our sample size is 5 and the parameter is mean. So sample size is small sample size, parameter is mu. So the test statistics would be, okay, small sample size, mu parameter. So this is our test statistics. So t statistic is our test statistics. So our test statistics with t statistics, which is x bar minus mu divided by s over square root of n. Let me double check that. X bar minus mu s divided by square root of n. Okay, so this is x bar is 4.6 minus mu is 6 divided by standard deviation 1.3 divided by square root of n, which is 5. So this is equals to 4.6 minus 6, which is negative 1.4 divided by 1.3 divided by square root of 5, 0.58, negative 1.4 divided by 0.58, that is negative 2.41. So let's draw our rejection region. alpha is 0.05. So this is test statistics. This is our t. Now what is the degree of freedom? So degree of freedom, n is 5, sample size is 5, degree of freedom is n minus 1, which is 5 minus 1 equals to 4. Then let's find the t. Now alpha is 0.05 and the degree of freedom is 4. So in our t table, okay, what was our alpha? Alpha is 0.05. 0.05. So degree of freedom is 4 and alpha is 0.05. 0.05. So 4, 0.05, the corresponding 2.132. 2.132. So if our t is on the right side, okay, if our test statistic is on the right side, is greater than 2.132, then we reject our null hypothesis. Now what did we calculate our test statistics, which is negative 2.41, so which is over here, negative 2.41. So our test statistics is this is the test statistics, and this is not in the rejection region. So we okay, now we fail to reject. Yes, we fail to reject our null hypothesis. If you have this test statistics in the rejection region, then we reject null hypothesis. Let me go back and double check what we did here. Let me since okay, skate so the decision is that when our test statistic is in the rejection region, we reject null hypothesis, and if our test statistic is not in the rejection region, then we fail to reject null hypothesis. So in part B, we have to test the hypothesis that the mean of the population 6 against this alternative hypothesis. So our alternative hypothesis is mu not equals to 6. Null hypothesis would be mu equals to 6. Alpha is 0.05. Our test statistics would be same. So t of t would be x bar minus mu divided by s over square root of n, which would be negative 2.41. So let's draw our rejection region. Since this is a two-tailed test, we have here from the 2.132. This is 2.132. This should be negative 2.132. So if our test statistic is here or here, then we reject our null hypothesis. So our test statistic is negative 2.41. So it should be here, negative 2.41. Now, since our test statistic is in the rejection region, we reject null hypothesis. This is the decision. So if it's in the rejection region, we reject null hypothesis. If the test statistic is not in the rejection region, we fail to reject null hypothesis. The next example, for safety reason, calf dehorning has become a routine practice at a dairy farm. A report by a continental government organization stated that 80% of their continent's dairy farm carry out calf dehorning. A later study published in a reputable dairy science journal found that in a sample of 641 dairy farms in the continent, 523 Dehun calves. Does the journal's study support or refute the figure reported by the government organization? And we have to test using alpha equals to 0.05. So let's start with a null hypothesis, alternative hypothesis. Since we are given with a percentage, our parameter is p, and we want to test. Now we want to. The question is, does the journal's study support or refute? It means we want to know whether the percentage is 80% or not. It means we want to know whether p is less than 80% or greater than. It means p not equals to 0.8 and p equals to 0.8 is our null hypothesis. Now let's find the test statistics. So here we have our sample size 641 and our parameter is p. Now is 641 large enough? So let's check that, which is n time p, which is our n is 641 times p is 0.8. So this is 641 times 0.8, 512.8, which is greater than 15. N time q, our n is 641 times q is 0.2, 1 minus p, so 641 times 0.2, that's 128.2. This is also greater than 15. So in both of case, n time p is greater than 15, so 641 is large enough. So our test statistic would be g of t, it would be p hat minus p divided by pq divided by n square root. Okay, let me double check this one. Okay, so here large sample about p, so p hat minus p divided by p time q divided by n. Okay, so that looks good. Now let's go ahead and find substitute. Now what is p hat? We calculate p hat from this sample. So out of 641, 523 is Dehun, so the fraction p hat is 523 divided by 641. So this is 523 divided by 641. So 0.8. So 0.816. So p hat is 0.816 minus p is 0.8. So 0.8 times q is 1 minus p, which is 0.2, n is 641. So this is equals to 0.816 minus 0.816 minus 0.016 divided by square root square root 0.8 times 0.2 divide 641. Let me double check. 0.8 times 0.2 divide 641. 0.01 6, which is 1. So our 0.016. Okay, so let's find the p-value. This is two-tailed test, so our p-value would be on two side. So test statistic is 1, -1. So this area and this area is our p-value. So this is 0. Let's find this area from normal table. Our g is equals to 1. So when g is equals to 1, what is area? 1 is here, 3 4 1 3, 3 4 1 3. So this is 0.3413. In the similar way, this is also 3413, not 16. So the yellow region would be 0.5 minus 0.3413, and this is 0.5 minus 0.3413, 0.1587. Our p-value would be, so this is also 0.1587, 2 times 0.1587, and this is equals to 0.3174. And determine the proper conclusion. Okay, our alpha is 0.05. So alpha is 0.05. Rejection region. So let's draw that rejection region for two-tailed test. So the rejection region, this is rejection region, this is rejection region. Sum of these two area, this 2 is alpha, which is 0.05. So this would be half of 0.05, which is 0.05 divided by 2, 0.025. Now let's find the g for this point. This area would be 0.5 minus 0.025, 0.475. Now use the g table, 0.475. So 475, the corresponding g is 1.96. 1.96. So this g is 1.96. This is negative 1.96. Now where is our test statistics? So test statistic is 1. 1 has to be somewhere here, right? So 1 is here. So since our test statistic is outside the rejection region, we fail to reject null hypothesis.